This last section in Chapter 4 talks about solving polynomial inequalities. Now, you've done these as linear functions before, but now we're going to talk about the multi-dimensional graphs, and we're going to be looking at where these graphs actually hit zero and where they go above and below zero as far as values of y go. So what we're looking at is where the function is less than zero, and this would, of course, be negative values of y. In other words, the function would be less than 0, y would be less than 0, and where they go above 0. So these would be positive functions or positive values of y. So negative y's, positive y's, and these are all polynomial functions. So we're going to be finding the real solutions, the zero solutions, and these zeros are going to be our boundary points. In other words, that's going to be where they cross the x-axis still, but those will also bound the negative and positive values of y's. So then you can do one of the two things. You can choose a representative number, a test value, in between those boundary points and test. Is it positive? Does it turn out positive or negative? Or you can use your graphing calculator. I'm going to use my TI-84 at this point to check it out. So you can do one of those two things. Then you'll give your solution set. We'll use both interval, and we'll use writing it on a number line, interval notation, and the number line. And let's see how this first one looks to us. So we have a polynomial here that's already been factored. And you recognize it probably as a quadratic equation that's already been factored. It was already set as an inequality. All these points are less than 0, so that's not the issue. What we'll do is set each of these factors equal to 0, and that will give us our boundary points. So I'll say x minus 5 is equal to 0, and I'll say x plus 2 is equal to 0, and I'll find that x is equal to a positive 5 and x is equal to a negative 2. Now, those are, of course, not going to be parts of the inequality. Those are going to be the boundaries, okay? Now, when I set out graphing that, I'm going to look at it like this. I would put negative 2 here. This is my x number line, and this is going to be a positive 5. And the only thing I don't know is I know this is a graph that goes up and below the line. I don't know whether it goes above the x-axis here or below. And the same thing for the ends of it. I don't know if it's going up or above or below. So what I'm looking for here is values of the function. The function is over here. The function less than 0. In other words, where is y less than 0 is my question. And of course, this is my boundaries. These are my x values, so I'll check an x value. I'll say, well, what about, let's look in the middle. Let's check the center of it first. Let's check maybe x is equal to 0, right? We'll set x equals 0, and if I plug that back into my function, I have 0 minus 5 times 0 plus 2. And all I have to do is figure out, is that positive or negative? Well, this is going to be negative 5 times positive 2, and that gives me negative 10. It's going to be down here below 0. Now, if one point between my two boundaries is below 0, then they're all going to be below 0. So I can sort of sketch that in, and I'll say, okay, I don't really care how far. I'm not trying for accuracy. I'm just trying for above and below 0. I know it crosses at positive 5 and negative 2, and here I know this middle part, this between those two boundaries, is below 0. So what does it do past negative 2 and past positive 5? Well, I can check a point. I can go over here and look for an x equal to, and it doesn't matter what I choose so long as it's smaller than negative 2, I'll try an x of negative 4. When I say negative 4 minus 5, put that in parentheses, times negative 4 plus 2, and I just need to know, is that going to be a positive value or a negative? But I can check it out really quickly. That's a negative 9, and this is a negative 2. Well, when I multiply two negatives, I know I've got a positive. It is a positive 18. That part's not really as important as the fact that it is above 0. Over on this side, what is it? Well, if I check for a number like it doesn't matter, I'll try bigger than 5. I can try 6. 6 minus 5 times 6 plus 2. Well, that gives me a 1 times 8, which is going to be 8, positive value, bigger than 0. So now I have y's that are bigger than 0, y's values less than 0, y values that are greater than 0 over here. What is my function? What am I trying to identify? The ones where y is less than 0. So where is y less than 0? Well, here is where the function y is less than 0. In other words, the function of f of x, here is less than 0. Over here, this f of x, the function, is greater than 0. In other words, y is greater than 0. And down here, the function, values for the function would be, once again, greater than 0. In other words, y is greater than 0. What am I looking for, though? Well, I'm only interested in where y is less than 0. In other words, the center of this graph. So now I have to identify it. This would be, if I was graphing it, I would say all of these values in between these two numbers. This says don't include those two numbers. You could think about it as an open circle, or you could think about it as a rounded bracket. If I want interval notation, I say it starts at -2, doesn't include -2, goes all the way to +5, but it doesn't include that either. So both of these, the graph and the interval notation, are represented here. Let's take a look at another one. This time we're going to say x squared minus x is greater than or equal to 0. And this one is clearly not factored, but easy to factor. Let's just factor out an x. And then we have x minus 1 is greater than or equal to 0. But let's set each of these points equal to 0 to find the boundaries. Well, the first one is x equals 0. And the second one is x minus 1 equals 0, or x is equal to 1. My boundaries are 1 and 0. I can graph that pretty easily. This is an x value of 0. This is the x value of 1. I'm just pretending this is my x-axis. What does it look like in between these two, to the left of this one, to the right of this one? And I can find that. I'll find that out and find out which ones are going to be included in this greater than or equal to 0. So let's take a point over here, and let's say, what if x was equal to -1? Then plug it back into either of these equations. Either one will do. This might be easier to plug it into the already factored form. So I'll say -1 times -1 minus 1. -1 times, and inside parentheses here, -1 times -1 minus 1 is -2. Negative times a negative, of course, gives me a +2. So up here, I'm saying, well, this is above, isn't it? And I'll just sort of show. I'm just kind of graphing that as above 0 at this point, above the boundary, the x-axis here. What about in between these two? I'm going to have to go for a fraction for this one. I'm going to have to say x is equal to 0.5 or something like that. And then I'll have to say, well, which one is easier? 0.5 times 0.5 minus 1. Well, this is 0.5 times, this is 0.5 minus 1 would be a -0.5. Negative half. And I'm obviously going to get a negative number. I'm going to get a negative 0.25, right? But it doesn't matter what it is. It's negative, so it's going to go down below for this part of my graph. I'm assuming it comes back up and crosses it at this point. It looks like it's a parabola, and that makes sense because this is an x square, isn't it? So it's going to go down and up. Those would be the two directions it takes. And over here, greater than 1, let's pick x is equal to 2 maybe. And then I would plug in 2 times 2 minus 1. And I would say that's 2 times 1, or a +2. So I'm ending up with positive values here. So what am I interested in? I'm interested in where the function of x, or y, if you want to think about it that way, is greater than or equal to 0. Well, clearly here it's not. This is where the function is less than 0, isn't it? And where is the function greater than 0? Well, here's going to be my function greater than 0, isn't it? It's going to be greater than 0 here, and the function is greater than 0 here. Well, where is it equal to 0? Well, at these 2 points. So if I want to put this on a graph, I'd say right here it's equal to 0, so I can include that, can't I? And I can go all the way this way. Right here it would be equal to 0. I know it's equal because I found it. These two, this equal says it could be equal to that boundary point. and I found the ones that are greater than 0, okay, to match what my inequality polynomial asked me to match. So how do I write this in interval notation? Well, I have to start over here at negative infinity and go all the way to 0, and this time I do include 0. So that's the parentheses I'm going to need. And then I'm going to join that. Right over here, it's going to join with positive 1, isn't it? And it does equal the positive 1 and goes all the way to positive infinity. So I just put a gap in there. Between 0 and 1, I left it out. And that's what my graph looks like too. And we're going to do this again with the next page, with page 31. I've got a inequality that is really has a quadratic on this side of it, and it's not been factored. So my first step is to factor this. So it looks like it might factor simply. I'm just going to put it down like this and see if I can find the boundary points. So I know I have to set them to 0. It already had 0 on one side of the inequality, so that was already done for me. So I'm going to look at factors of 3 that would add to give me 4, and I know I've got to have 2 negatives in here. So factors of 3 add together give me 4 are going to be 3 and 1. And you'd kind of foil that real quick to check it if you were uncertain. But it looks like I'm going to have as boundaries x minus 3 equals 0, or x equal to a positive 3, and x minus 1 equal to 0. So x would equal a positive 1. Like I said, these are the boundary points. I can draw my number, my x axis here, and I can put 3, or 1 over here, wouldn't it be? And then 3 over here. So 1 and 3 is what I have. All right, now all I need to do now is say, where does this exist? Where is it going to be less than 0? In other words, this time I'm looking for, where is f of x less than 0? So I want the negative y values is what I want. And if you want to think about this as going on and being the x-axis, you can. So I would check the points over here. I would say, okay, where is this? It's going to be, let's try 0. Isn't 0 to this side? So I'd say if x is equal to 0 over here, and I plug in 0, and you could plug it into either of these equations. Sometimes it's easier to plug it into the factored form. So I'll say, well, this is 0 minus 3 times 0 minus 1, or negative 3 times negative 1, and it's going to be a positive value, isn't it? And so it's going to be up above at this point. Oops, it crosses right through that boundary point, doesn't it? What is it in between? Between 1 and 3, I could say, well, I can check out x is equal to 2, and I would have 2 minus 3 times 2 minus 1, and that gives me a negative 1 times a positive 1, which is a negative 1. So it's going to be negative between those two. I know it has to cross again, so I'll go that way. And then above 3, well, let's try the number 4. X is equal to 4. I'm going to say that means I'm plugging it in to the factored form of my inequality. I'll say 4 minus 3 times 4 minus 1, and that gives me a 1 times, and this is just times 3. Both positive numbers, I get positive. So once again, it goes up like this somewhere. I don't know where. But that tells me where the function is less than 0. Now, this is where the function is less than 0. This is where the y values are less than 0, right? Where they go below the x-axis. So this is where f of x is less than 0, isn't it? And on this side, f of x, the function is greater than 0. Over here, f of x looks like it is also greater than 0. So what satisfies my inequality, my polynomial inequality here, is just this middle part. And when I graph that, I say, well, it's got to be between 1 and 3. But because it doesn't have an equal with my inequality sign, I don't include the 1 or the 3. If I was putting it on as I was graphing it with on the number line, I would maybe use open circles for those two, or soft brackets like I have here. Now I want to try something with you. I'm going to show you how to do this. This is a simple one, but let's look at it with our graphing calculator. And I'm going to go to y equal and clear this out. And I'm going to enter this inequality. Now I can enter it in the factored form, or I can enter it as the original form. It doesn't matter. I'll go with the original form this time. I'm going to say x squared minus 4x plus 3. Now I can't really I don't really set it to 0. I'm just going to graph that function, okay, and see where it goes above and below the x-axis. So I hit graph, and I can tell, I knew its boundaries already. I checked them. I found 1 and 3. This is where x is 1. That's where x is 3. And look what it does. It is a perfect parabola. I sort of knew that because that's a parabolic equation, isn't it? Inequality anyway. And so everywhere below, looks like below 1, it's going to be positive. Above 3 is going to be positive. The only place it's going to be negative, y is going to be negative, is between 1 and 3, which is what I found when I checked the points. But my graph on my calculator told me the same thing. It might be a little bit quicker for you. Let's try a second one. This one is not set to 0. Now I have to have 0 on one side before I can even get started. So that's my first step. I'm going to move that negative 40 to the other side. So I have x squared plus 14x. And I'll say add 40 to both sides. That gives me a positive 40. And then I can say it is greater than or equal to 0. Now I can factor this side. And I'm going to look at factors of it. I'll go ahead and set these equal to 0 because I'm trying to find the boundaries at this point. And I know I have to have x plus for both of these. I'm looking for factors of 40 that add together to give me 14, and I know that's 10 and 4. So I have as boundaries x plus 10 equals 0, which means x would equal a negative 10, and I have x plus 4 equals 0, which means x would therefore be a negative 4. And I can set my number line right here and put those 2 points in. Negative 10 is smaller than negative 4. And now I just have to decide. I just need to know where are the y values, where does the function go above and below that x-axis, okay? And once again, to find that out, I can check points like we've been doing, or I'm going to go to my calculator and go to y equals. I'm going to zero out, clear the one we just did, and then I'm going to come in here and enter, and I'll enter this inequality here instead of, well, I entered that last time. Let's enter the factored form just for change of pace. I'm going to say x plus 10 inside parentheses, close the parentheses and start a new one, and then say x plus 4. Remember, you can use either the factored form or the non-factored form, doesn't matter. So x plus 10 times x plus 4, and let's graph this. Now I expected, it's almost not showing on my graph. I might have to change my window if it was a little bit further over, but it looks like that's going to be where x is equal to negative 10, and that's going to be where x is equal to a negative 4. Let's move the window over. I'm going to hit window, and I'm going to say in the x values, I want to start with an x of, instead of negative 10, I want to start with a negative 20. Now let's do it again. Yeah, it just moved it over for me, so it helps me to see it. Where is x? Where is y? What we need is where the function f of x is greater than or equal to 0, okay? That's what we have. That's what we're dealing with right here. Well, where it's greater than or equal to 0 is the two ends of the graph, right? So I'm going to say over here is where f of x is greater than 0, and over here is f of x is greater than 0, and in the middle is where f of x is less than 0. Remember, what we're saying is y is greater than 0, y is less than 0, y is greater than 0. We're matching it to our graph. If you wanted to technically look at the points, you could by going to the table and then comparing, okay, I want to check a point like negative 11. Well, let's go up here and see. At negative 11, y is positive, isn't it? At negative 8, maybe, y is going to be negative, isn't it? And at, well, let's try 0. Where is x equals 0? I've got a positive. So that's exactly what I graphed, or what I'm showing. I could put my, lines in here. I think I've done that. And I can say this is greater than 0 over here, less than 0 in the center, greater than 0 here. And I would graph what points I'm looking for. I need greater than 0, right? So I want greater than 0. And here it's also greater than 0 over on this side. And does it include these boundary points? Yeah, it did, because that's got an equal. So I'll color them in, make a solid circle here. Or I could use my brackets and say, well, it satisfies the inequality when I say negative infinity all the way up to negative 10. And negative 10 is part of the solution. And then I'll join that over here with negative 4 to positive infinity. Now let's take a look at one more of these. That's a pretty simple one. Then we're going to get a little more complicated. This time I need to do the same thing. I need to fix this so that everything's on one side. I've got 0 on the other side. And this time I've got 12x over here. So I have to subtract 12x. I also need to put it in order, in descending order from the highest exponent. So I'll say this is x squared. I subtract 12x. I'll put it right there. And then I had a positive 27, didn't I? And now I've got 0 on the other side. So that's my equation, or my inequality, and now I'm going to try to factor it. I'll set them equal to 0 because what I'm trying to do here is to find the boundary points. So I say, well, this is plus, and it says use two negatives. This is going to be x minus. This is going to be x minus factors of 27 that I could add together to give me a 12, or negative 12 would be 9 and 3. So I got a negative 9, negative 3. And I would check that real quick to see if it's right, and it is. So I draw my number line. I say, well, oh, wait a minute. X minus 9 equals 0, right? X minus 3 equals 0. So x would equal positive 9. X would equal a positive 3. So I'm going to set up. Here's where it's 3, and here's 9. And let's see if I can see, where is my solution set? Is it between these two, or is it on the ends? And I would check points to see, or we've done that. Let's go to the calculator. And let's put it in. This equation, either way, I'll do the x squared this time. And I say x squared, what was it? Minus 12x. And it's going to be plus 27. And I'm going to graph that. This time I need to move my window over a little bit, don't I? So I set it to be on negative 20 to positive 10. I'm going to set it to be negative 10 this time. And I will graph that again. Well, that's a little better. I know the boundaries are 3 and 9. And in the middle is where it goes below. So I'll just kind of quickly sketch that in my graph. It's going to look sort of like this. I don't have to be accurate with the points. I just need where is it positive, where is it negative. On this end of my graph, the y values are greater than 0. In the middle, the y values are negative, or less than 0. And over here, the y values are positive, greater than 0. What is it? The graph is looking for less than or equal to 0. The function, or the y values, f of x, less than or equal to 0. So they're looking for just this center part, right? So I'll go ahead and fill that in. And I'm going to include 9 and include 3, since it did say less than or equal to 0. So how would I write that in set notation? I would say, well, we go from 3 to 9, and we include both the 3 and the 9. That's where y is less than 0. Now, problem 6 on page 32 is a bit of a challenge problem. So you might want to put a star by it, because this one's a little bit different. This one, as you see, is going to turn out with some imaginary numbers as boundaries, and we're going to see what that means for our function. So first, I've got the function on one side. It's been set as an inequality less than or greater than or equal to 0. So now all I have to do is try to factor it. And I would try to factor it by our usual method, finding those boundary points. And this time, no GCF factors out. I have to set as an x plus and an x plus. And then I have to try one of my methods to see if it'll factor. So I go over here and I say, okay, 2 times 8 gives me a 16. And this is a 3, and I would come over here and set these factors to be 2x, and both of them plus. Okay, I've got it set up. So I'm checking to see if I can find factors of 16 that will add together and give me a 3. 16 times 1, 8 times 2, 4 times 4. I have no other factors of 16. So really what I'm saying is this will not factor. I cannot factor it. So I'm going to have to use the quadratic equation. So now I'm going to look at the A term, the B term, and the C term. And I'm going to say, this is going to say that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c. It's all under the radical, and it's all of that is over 2 times a. And at that point, I check it to make sure I filled all that in right, because that's where most mistakes are made in the quadratic. And it is negative 3 plus or minus. And when I look at all of this under the radical, what I have is 9, and that's going to be negative 8 times 8 minus 64. Well, 9 minus 64 gives me a negative number, negative 55. And that's where my first alarming note comes in, because I know that's going to give me, square root of a negative is going to give me an imaginary number. So this is over 4. But there's nothing I can factor out, no perfect squares inside 55. So what I have here is negative 3 plus or minus the square root of 55. And outside of the radical, I have the imaginary number I, because I factored out the square root of negative 1 as an I, and all that's over 4. That's about as simple as I can get this. So what exactly does it mean that my boundary points are not real? Now this is what I wanted you to get. These, the boundary points, are imaginary numbers. So they're imaginary numbers. So we have no real roots. No real roots, no real zeros, right? So what that means is it never crosses the x-axis. Okay, that's fine. It never crosses the x-axis. It's a parabola. It's either all above the x-axis or it's all below the x-axis. And that's what I have to determine here. Okay, so if all of them are positive, if all these values come out to be all y's are positive, and then I would say I have the all set of real numbers, okay? I go from negative infinity to positive infinity. If, however, it's below and all the y's are negative, then I have no solution. Okay, and that's the way I'm going to determine it. How am I going to do this? Well, I'm going to look at my graph and my calculator and see what happens. And I'll come over here, clear out y equals, and I'll just enter it as 2 x squared plus 3x plus 8. And I want to see where it takes me. So see if I can graph that. And there it is. It is all positive values for y. So what is my solution set? Negative infinity to positive infinity is my solution set. All real numbers, okay? It's never going to cross this axis, though. It has no real number roots, is what we're saying. Now, why I said that if all y's were positive, then we had all sets of real numbers from negative infinity to positive infinity was our solution set, is because that's what our inequality is looking for, where the function is greater than or equal to 0. If we have positive numbers, then the entire function is positive because it doesn't cross the axis. If it was below 0, if all y's were negative, well, that's not what our function is looking for, is it? It's looking for only the values where we have positive y's. So if we have negative y's, then we don't have a solution set. Now, you could check it without the calculator by plugging in any number at all for it and seeing if it came out to be positive or negative. And when I plug a number in like, okay, let's try x equals 1, I would plug it into the original function, and I would say, well, that's 2 times 1 squared plus 3 times 1 plus 8, and all I need to know is it a positive or negative number? And when I did that one, it came out with 2 times 1, which is 2, plus 3 times 1, which is 3, plus 8, and you can tell already it's going to be a positive number. It's positive 13, but all I really care about is that it is positive. And that says everything in that graph is therefore going to be positive, because what we know is that it never crosses that x-axis, so it can never go negative. Okay, let's go back and try a fairly normal one this time, but this one kind of has a lot of terms on each side. I need everything to go to the other side, so what I'm going to end up doing is adding 13x squared and subtracting 18x. I think I can do that in one step, but I'm going to write it down. I'll add 13x squared, I'll subtract 18x, I'll do the same thing over here. I don't have to add anything to this 6x cubed, but I do have to add 13x squared to 10x squared. I end up with 23x squared, and I'll subtract 18x from nothing. There's no term over there. And then I have zeroed out this side. So there's my function. And you can see I have a GCF of x, and I'm going to factor that out. So I'll have x times 6x squared plus 23x minus 18. And all of that is going to be greater than 0, or I could say equal to 0, because now I just want to get the roots, right? So I'll say, or the boundaries here. I'm going to say x, and I'm going to see if I can factor this one. And I'll set it to 0 because I'm looking for boundaries. Now, once again, I'm going to try any factoring method that I'm familiar with. I'll go with the diamond method. I say 6 times negative 18. When I do that, I get negative 108. And then I list my b term down here, 23. I'm going to kind of set my factors up with the coefficient of the leading term and x. And then I say, well, one of these factors has to be positive and one negative. They'll both have x's in them. So I'll go ahead and set that up. And now I'm ready to see if I can come up with factors of 108. Now, I don't know factors of negative 108. So I take it and say, okay, well, 2, I'll use my calculator. 108 divided by 2 is 54. And those will not combine to give me 23, so I'll try 3. 3 works. 3 times 36. But there's no way that I can subtract those. I'm going to be subtracting these to get 23, and that's no way that works. Let's try 4. And 4 does divide, and I get 4 times 27 gives me 108. And that would subtract to give me 23 if I had a positive 27 and a negative 4, and that's what I'll do. Except I can reduce these, can't I? I can say, well, 3 goes into both 6 and 27, so this is really 2 over 9. So I have 2x plus 9. That's my first factor. And then I go over here and say, well, 2 goes into both of them. So I got 3x minus 2. There, I have my factors. FOIL to check them and make sure that you've got it right and you got your signs right. And then I can set and find my boundaries. X is equal to 0 is one boundary. And then I'll say 2x plus 9 equals 0. 2x, therefore, would equal a negative 9. And x is going to equal a negative 9 halves. Okay, that's another boundary. And then 3x minus 2 would equal 0. And I would say 3x would therefore equal a positive 2. And x is going to equal 2/3. So if I look at that with a number line, I need these points in there. I need negative 9 halves. And then in between them, there's the 0. And then over here somewhere is 2/3. So I know that this is a degree 3 function, isn't it? So it's going to go down and up and down, or up and down and up. I don't know which one it's going to do. I have to check some points in between them to find out. So I can do that, or I can look at it with my graphing calculator. I'm going to choose this time to do the calculator. I'll go to y equals and clear this one, and I'm going to enter it right here. This is the function that I finished, that I set it to greater than 0, so I'm going to enter this function into my calculator. I'm going to say 6x to the power of 3, 6x cubed plus 23x squared, and what's next? Minus 18x. And check it out. Is that what I got when I finished getting everything on one side is 0? 6x cubed plus 23x squared minus 18x. Let's see what this looks like when we graph it. Wow, it's way off the graph, isn't it? Now, maybe that's okay because I can tell it starts and goes high, goes positive, goes negative between these two, and then it goes positive again. But if I wanted to make sure everything got on the graph, I would just kind of quickly check out my table. I need to know how high it goes when it's between 0 and negative 9/2, don't I? So let me see what it says in the table. Between 0 and negative 9/2, let's see, where is that? It's going to go up to like 99, so I need it to max out probably at 100, y of 100. And then I want to know where does it go between these 2 points, right? I want to know how far down it goes. Let me see that. I really got that. I just need to max it out at 100. Let's fix the window so that the y max is 100 instead of 10. And then maybe I do increments of, well, let's just see what it looks like. Not going to help me. Well, it helps me some. It crunched it up a bit, but it's really hard for me to read this. Let's see if I can set this window a little better. And I'll say, instead of y increments of 1, I'll make y increments of like 20. Something like that might help me. Okay, that's a little better. It sort of tells me where it is a little bit. I know it's going positive between these 2 points, isn't it? So I could say, well, graphs like this, positive between these two, negative, although it's just a little bit, and those are very close together. My graph is not drawn to scale at all, but I can say here, over here, f of x is definitely less than 0. In between these two, f of x is greater than 0. Between these 2 points, f of x is less than 0 again, and over here, f of x is greater than 0. What am I looking for? In this particular one, I'm looking for y, f of x greater than 0. And that would be right here and right here. All the positive values for y. So I'll set my interval notation. I'll say, well, it starts at a negative 9/2. Because it doesn't have an equal, it doesn't include it. And it goes all the way up to 0, not including that. Then I have to join it with this part over here, don't I? Which starts at 2/3 and goes all the way to positive infinity. So if I were to graph it, I've kind of jumbled it up. You would have these points with an open circle at each end, and then you would have these points, open circle here, all the way to positive infinity. Now let's take a look at another one that's going to give us a little bit of trouble and see if we can show the opposite of what I showed you in number 6. So you might want to put another star by this one. Number 8 is an unusual problem. I look at it first and I think, okay, I'm going to try to factor it. It's already set up less than or equal to 0. So I would say, try my diamond, and I would say 8 times 3 would give me 24, wouldn't it? Whoops, this is what I call what happens when you don't look very closely at your problem. That's not supposed to be the first term. 7x squared is the first term. Then plus 8x plus 3 less than or equal to 0. Okay, so now what's the top of my diamond is 7 times 3, which is 21. And the bottom is 8. And then I would say I need to put 7x plus here, and I need 7x and plus here. I'm looking for factors of 21 that will add together to give me 8. And all the factors of 21 that I can think about are 21 times 1, and then 2 won't divide into it, 3 will. 3 times 7, 4 won't, 5, I mean, I'm done. And none of these add to equal 8, so I can't really factor. So I cannot factor. I've got to go to the quadratic equation, don't I? So I look for my A term, here it is, my B term, and my C term. So my quadratic equation would say negative b, which is going to be a negative 8, plus or minus the square root, b squared minus 4 times a times c. And all of this is over 2 times a. and kind of check it real quick just to make sure we inserted our numbers correctly. Okay, under this radical, this is going to be 64, and it's going to be minus, and that would be 28 times 3, right? And 28 times 3 would be minus 84. So when I look at that, that's going to be negative 20, isn't it? Let's rewrite it. Negative 8 plus or minus the square root of negative 20, and now I'm over 2 times 7, which is 14. Now, negative 20 has a perfect square in it, and it also has the square root of negative 1. So when I finish with this term right here, what I'm going to have out is I'm going to pull out an I. I'm also going to pull out the square root of 4. I'm going to make this a negative 1 times 4 times 5, right? All under that radical. When I pull this out, I get the I. When I pull out the square root of 4, I'm going to get 2. So I'll say 2I. What's left under the radical is the square root of 5. So I want to rewrite this answer. I've got negative 8 plus or minus, and I'll say 2 times the square root of 5 times I. And that's all over 14. Now look, I can reduce all of these. I can divide 2 into each of these, the coefficients, the leading terms, right? So what is my term going to be? Well, negative 4 plus or minus the square root of 5. And the I is separate, of course. And that's over 7. And that's really my boundaries. But as you can tell, they're not real, are they? They're imaginary numbers. So I know all of my points are going to be either above or below the x-axis, no crossing the x-axis. Why? Because I ended up with imaginary points for my boundaries. So all I have to do is take one point on this in this function and check it and see if it comes out to be positive or negative. Now let's just take a point that's easy for us to do the math. Let's take x equal 1. If x is equal to 1, and I plug it in here, it doesn't matter which one I plug it into, but I'll plug it in here, what I have is 7 times 1 squared plus 8 times 1 plus 3. Well, that's just 7 times 1, or 7. This is 8 times 1 plus 3. And you can tell this is going to turn out positive, really, isn't it? Isn't this going to be 15 plus 3, which is 18? So all I really care about, though, is it was a positive number. It's a positive number. Now, I know if that point is positive, since this doesn't cross the x-axis at all, everything is going to be positive. I'm going to have my x-axis like here, and I'm going to have, this is going to be some type of parabola, isn't it? It'll go up like that, won't it? Somewhere above the x-axis. Is that going to satisfy my function, my inequality function, which said all y's had to be below 0? In other words, find any y in this one that's below 0. There are none. So I'm going to have, this is going to tell me there's no solution to this one. You could plug this one in to your calculator, and you would have found, instead of plotting this point, you would have found the same thing. You would have found the graph was all above 0.